Good morning, dragons. Now, we've gone over several activities from this packet already. We had activity 3.1, which was our introduction to multiplication equations. We did activity 3.2 on a Zoom meeting together where we worked with multiplication equations that had fractional coefficients in front of the variable. And now we're going to go into solving more complex multiplication equations. Let's consider 4/5 x is equal to 1/10. How is this equation different from the equation you solved in the previous activity? So if you joined us for 3.2, you know that we had fractional coefficients, but our constants were whole numbers. Now, the numerical coefficient and constant are both fractional values. So what does that mean? It means that here, this guy here, he's a coefficient and he's fractional. And in the last lesson we talked about unit fractions. This here is called your who. What is that guy called? That is, in fact, your variable. And then this here, many people called it a term during class. Not only is it a term, but is a constant. It is not attached to any variable. It will remain unchanged. Let's take a look at how two different characters solve this. Compare the two solution strategies proposed by Landon and Zoe. Landon takes 4/5 x equals to 1/10, and he decides to scale 4/5 up to 8/10. Well, let's think about that for a minute. Why would he choose to do that? I'm looking for a match. I'm trying to figure out Landon, and I'm seeing, well, I'm thinking he's doing that because he wants a matching denominator. I'm not sure yet why he wants a matching denominator, but that is my instinct. Now he's got 8/10 x equals 1/10. How is that useful? How is 8/10 x equal to 1/10 useful? I see both sides are divided by 10. Well, if they're both being divided by 10, that's like the division property of equality. I wonder if I could make that 10 disappear. I wonder if that would be useful for me. And I think I can make it disappear. If both sides are being divided by 10, I could do the exact opposite. I could multiply both sides by 10. And I know that that would create 1. Because it would be 10 over 10, which would be 1. So these things are inverse operations, so they undo one another. So you're left with 8x is equal to 1. Well, that does me all fine and good. I know what 8x's are worth. But the entire purpose of the problem is to know what just 1x is worth. So I know what 8x's are worth. So I really do need to decompose it, because I need to know the value of just one of the x's, not 8 of them. So then I watch Landon go, okay, I'm going to take this 8x, and I'm going to break it up all individually into all its individual x's. And if that's true, if I break 8x up into 8 parts, I need to break 1 into 8 parts. And if I do that, it's 1/8 and 1/8, 1/8. And then I start to see Landon's thinking. Landon sees that x is the same as 1/8. Now, the reason I take my time with Landon's solution is because when I read his solution, it did not come naturally to me. If you looked at Landon's solution, it did not come naturally to you either. That's okay. Some of you, this might work. Some of you, it may not. Let's take a look at Zoe's solution and see how we feel our comfort level with that one. So Zoe starts with 4/5 x is equal to 1/10. Okay, that looks like something we've studied before. We know we need to get to a full x. And I can see that Zoe has decomposed 4/5 x into unit fractions. So she's like, I need to break this up. I'm going to do this, and this, and this, and this. So I'm going to break it up into 4 parts. So that means she's like, oh, I got to break 1/10 up into 4 parts. I got 1, and I got 2, and I got 3, and I got 4. So it's 1/10 divided by 4. That's what she had to do there. Wonder what that comes to. 1/10 divided by 4. How about 1/10 divided by 40th tenths? Because I need common denominators. And then I'm like, okay, that's 1 divided by 40. That is 10 divided by 10. I've done this before. So that's 1 over 40 over 1, which is 1 over 40. So each of Zoe's miniature boxes is 1/40th. That's when she took the extra box. She goes, this is 4/5. Boom, 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 boom. I need an additional box here because I need to compose. She's like, I need this extra 1/5 because without it, I can't create one full x. We've seen this. This is not that unfamiliar to us. She wanted to build a full x. And we need that to mirror whatever this is down here. So Zoe's working along. She's like, okay, so this 1/5 x is whatever this value is. You may say it's 1/4 of 1/10. Well, I actually already did the math for you on that. Because if 1/10 had to be broken up to 4 parts, we know that each of these smaller parts was 1/40th, which forced it to be 1/40th. And now I know what 1/5 x is worth, but I need to know what all of x is worth. So I have to take all these components and add them together. 1, 2, 3, 4, 5. I can add all the numerators together and see that it's 5/40ths. That could probably be simplified, right? Yeah, 5/40ths is the same as 1/8. 1/8. How do I know how to scale it down? Using the greatest common factor between 5 and 40, I would divide the numerator by 5. I would divide the denominator by 5, and I would get the result of a numerator of 1 and a denominator of 8. So now an x is worth 1/8. And an x was worth 1/8 in Landon's model as well. So to recap with Zoe, she had the 4/5 x equal to 1/10. That's her original equation. That's our original equation. She said, I need to build it up. I need to compose because 4/5 x is not a full x. But she was a little hesitant there. Now think back. Vanessa did this in a previous lesson. Vanessa's like, I am going to decompose 4/5 into fractional, not only fractional coefficients, but unit fractions. And if I decompose it that way, then I'm going to decompose the constant in the exact same way. And that helped her figure out how to build it up. Explain Landon's solution strategy. What type of reasoning did Landon use at the beginning of his solution? What are your thoughts? Landon used ratio reasoning to scale up from 4/5 to 8/10. Once the denominators were the same, he was able to set the numerators equal to each other. We did get the numerators equal to each other, but I also used some properties in there too. What type of reasoning did Landon use at the beginning of his solution? Landon used ratio reasoning to scale up. He wanted to get common denominators. How did he know to write 8x equals 1? I don't think that comes naturally to every learner. How did he know to do that? He's really thinking about either one of two things here. He's either thinking about the fact that both sides were both divided by 10, so that's a property, the division property of equality. And if I divide both sides by 10, then the numerators were equal to each other, because the division by the denominator was the same. Or he was thinking, if I do this, and then I apply inverse operations, I can kind of make the denominator not be there anymore. So then, by default, I'm left with the numerators set equal to one another. So he had two options here. He could have used properties of equality, or he might have used some inverse operation thinking. He could rewrite the equation using properties of equality. Both sides of the equation were divided by 10. And because they are both divided by 10, it makes me think of the division property of equality. The division property of equality was presented back in lesson 1. Will scaling up always work? This strategy works well when it is easy to determine a common denominator. Now, I've been studying algebra for a long time, and when I learned it as a kid, we didn't learn anything like Landon's solution. And even after careful analysis, Landon's solution doesn't come that naturally to Mrs. Morgan. So, if this is not comfortable for you, I completely understand. Now, looking at Zoe's solution, I do understand Zoe better. We've worked with something like this before. I can see what she was thinking. I know she's trying to create one whole x, and she's building up. So you do what works for you. One of these probably feels more comfortable than the other. Explain how Zoe's solution is similar to the other equations you have solved with bar models. The big thing here is Zoe divided her model into fifths. So then determine 1/4 of the constant 1/10. So each 1/5 x is equal to 1/40. So all of the x is equal to 5/40. Zoe divided her model into fifths. In order to divide her model into fifths, she had to divide 4/5 by 4. Then, she determined how to do that to the constant. So she divided her constant by 4. And they're saying it kind of backwards here, to what I feel she did. We did 1/10 divided by 4. We decomposed it. They're just saying that it is 1/4 of 1/10. It's the same difference. Because either way you say it, we know that each 1/5 x is equal to 1/40. So 1 full x, 5/5 x, which is 1x, is going to be 5/40. Let's see if we can use one of their methods on the next page. We'll do one together. Let's try number 4. And I am going to use Zoe's. I'm going to use Zoe's. So take a moment, pause the video, see if you can use Zoe's. If you feel like using Landon's strategy, go ahead and challenge yourself. Or go ahead and use Zoe's strategy and solve this. Once you're done, unpause it and check your solution. So hopefully you took a moment to work this out. And I've never tried this one before, so if I make an error, I'm making it simultaneously as I'm recording this. So I'm seeing that I've got 3/4 x. And I'm feeling like I want to chop that up. To have 1/4 x, 1/4 x, 1/4 x. So I just divided this into 3 parts, which would mean I'd have to divide this into 3 parts. Off the top of my head, I do not know 2/5 divided by 3, so I'm going to have to work it out. So that would be 2/5 divided by, let's say I need to do times 5/5, which would be 15/5, which would be 2/15 over 1, which is just 2/15, which cannot be simplified. Okay, so each one of these guys is 2/15. Now I need to build up. Because I need to know what 1 full 1 is worth. So I would need another 1/4 x there, because that would be 1, 2, 3, 4 of the 4 parts. Likewise there. And then I need to know what I'm going to build up here to finish it. So this is 2/15 here, is a little baby part. And if I add 2/5 to 2/15, I should get what x is. Let's see, to do that, I either do 2, 4, 6, 8/15, And I can test that and do times 3 times 3. That would be 6/15. Yes. Okay. So now I created a full x because I built up here, I composed. And then I have like denominators here, so I can just add the numerators. 2, 4, 6, 8. 8 of the 15 parts. There you have it. So we took Zoe's method, we decomposed the original expression on each side. We decomposed it into 3 parts here, then we decomposed it into 3 parts there. We built up to create one whole instead of just having a fractional part. That gave us one full x, and then this mirrors this. So this will be the last of the complex fraction models. In the next lesson during Zoom, we're going to work together and find the most efficient way to solve for a variable in multiplication equations. Thank you, Dragons.